Going to talk about is a sphere. Okay, a sphere is essentially just a ball, right? Some type of ball. Could be like might seem like a globe. A basketball. Anything that makes that type of shape. And we're going to do a couple of different things with spheres today. We're going to talk about surface area. We're going to talk about volume, kind of like we did yesterday with cones. All that we need to find the surface area of a sphere is its radius. Okay, there is no height, there is no slant height, none of that kind of stuff that we've been doing the last couple of days. We just need the radius. But one thing you're going to have to really pay attention to is sometimes they give me the diameter. So if they give me the diameter, then I always got to make sure that I divide by 2. The formula for surface area, if I imagine like a baseball or a softball, right? That would be a sphere. And a baseball and a softball have all of the laces on them. And basically, if you were to see them being built like in a factory or whatever, then it's got like a core to it in the middle, right? And then it's got the cover to it. And then those covers are like laced together over the top of the core to make the ball. And if you were to look at what it would look like before it hits or as it's on its factory line, then it kind of looks like 2 peanut-shaped pieces, okay? And I'm going to try to give you the best idea, basically, of what's going on here. Basically, this is a part of the cover, this is a part of the cover, this is kind of slid into here, and then it's wrapped over the top, and these are wrapped up. So essentially what's happened here is we have 4 circles being formed. We've got a circle here, we got a circle here, we got a circle here, and we got a circle here. Okay? Those 4 circles are going to cover up the core of the ball, or whatever it is. Okay? And so the formula here for the surface area is 4 times pi r squared. The area of one circle is pi r squared. But if I have 4 of them, it would be 4 pi r squared. So 4 circles would essentially cover up the outer part of that ball, whatever kind of ball it is. So on this very first one, my radius is 8. So in some ways, spheres are kind of nice because there's only one piece of information that I need. When we did all the other figures, we needed some type of height, we needed some other pieces of information. So here, we're just going to go 4 times pi times 8 squared. Because we're dealing with pi again today, sometimes we may leave our answer in terms of pi. 256 pi would be my exact answer if we were wanting to put that into a decimal. We would just type that out, and we get about 804.25, depending on what the instructions ask us to do. Are they asking us to leave it in terms of pi or as an exact answer, or do they want us to round to the nearest 10th, 100th, whatever decimal place? Okay, these two are both a little bit different, still using the same formula, still finding a surface area of the sphere. What do I notice about the one on the left here? What am I given? Yeah, it goes all the way across, right? So the diameter is 40. We don't want the diameter. We want the radius. We want half of the length. So you have to pay attention to what that line is. Is it half the circle? Because we got a circle on the inside of that figure, right? Or is it the entire thing? So here the radius is 20. And so then it's just 4 times pi times 20 squared. Okay. Just make sure you're using the radius. The bigger the radius is, the bigger the surface area is going to be as well. So here we get like 5,026.55. All of these here are area. So area is always square units. So it's just feet squared. Okay, this one here. We did one that gave us the radius. We did one where they gave us the diameter. Here we see C. What do you think C would be? Circumference, right? A sphere has an inner part that's a circle. So if I had a ball, it would be the widest part of that ball, the circumference on the outside of that ball. What would be the circumference of the ball, right? You got different sizes of basketballs, for instance, based on like what age you are. Then you might have a little bit bigger ball the older you get. And so the circumference of that ball would be usually how they're sold in the stores. Okay, what would be the circumference of that? They get a little bit wider, we get a little bit bigger the older you get. So here we know that the circumference is 12 pi. That's what's given to us. We're wanting the radius. We need the radius. The radius is what we're looking for. So the circumference is 2 pi r. Okay, we talked about the circumference back in chapter 10, or chapter 11, I think it was. We're going to plug in 12 pi for C. And we need r. Okay? And one of the nice things here is whenever I see pi on both sides of the equation, what's going to happen here? If I want to solve for r, the first thing I would do is, what can I do with the pi?
You can just cross them out.
Yeah. If I divide by pi, it just makes those two cross out. They're just going to knock each other out. As long as I have a pi on both sides, then I can just knock it out. If they had given me just 12 and not 12 pi, then I would actually have to take 12 divided by pi. So that's one thing you'll have to pay attention to. Am I given pi in my circumference, or is it just 12? Those are two different things. So now we have 12 equals 2r, and then we can divide by 2, and we get the radius is 6. But we're wanting to know what is the surface area, so now to finish it out, we're going to plug that in for r and get our surface area. And it says let's round to the nearest hundredth, so we get 452.39 feet squared. Okay, so that's surface area. We need the radius. If we don't have the radius, what can I do to figure out what the radius is? Okay, this one is simply just asking what is the diameter, okay? So there's a lot of different questions that could be asked here. Obviously, surface area is one of them. This one wants to know what is the diameter, okay? So to find the diameter, we know that surface area is pi r squared. They gave us the surface area right here. They're telling us that surface area is 20.25 pi. I know a lot of times when I write surface area, I like to write SA for surface area. A lot of times the book just uses S. S is surface area, so you'll see it both ways. I write it SA, they write it just with S, but same thing. So we're going to put 20.25 pi equals 4 pi r squared. We want the radius, okay? We got to find the radius. So we got to work backwards. Same thing. The first thing I would do here is we got a pi on both sides again, so I can just divide by pi. So now I have 20.25 equals 4r squared. What would I do next? Divide. Yep, got to get rid of the 4 next. So now we're going to divide by 4. So 20.25 divided by 4. What's that give us? Okay. 5.0625. Yep, okay. And I still have r squared over here. So how do I get r by itself? How do I get rid of that square? What's the opposite of squaring something? Square root. Yeah, we just got to take the square root of both sides. Okay. Does it come out to be a nice exact answer? Or is it a big long decimal? 2.25. Okay. So r is 2.25. But then just remember at the very beginning, this would be really easy to miss here. We found the radius. What do I have to do to the radius to get the diameter? Just double it. Yeah, just take it times 2. So my diameter would be 4.5 centimeters. Okay, I'm going to change this problem just a little bit because I want to show you a little bit different one. We already did one like this with the pi. If I want to find the radius, here instead of, I'm going to make it 30 instead of 30 pi. I'm going to take the pi off of there. So I'm going to show you what this would look like and how we would go about this. Okay, sometimes there's a pi on the answer, sometimes there's not. This time we're just saying the surface area is 30. A lot of times if you look for something in the store, it's not going to tell you that the surface area of something is 30 pi, right? It's going to tell you that it's 30 centimeters or whatever it is. So in this case, I'm going to set 30 equal to 4 pi r squared. So if I want to find out what the radius is here, we got to do several different things, okay? I got to get rid of the 4, I got to get rid of the pi, and I got to take the square root. It doesn't matter which one of these you divide by first. But it does matter if there's no pi over here. If there was a pi, the pi's would just knock each other out. But because 30 doesn't have a pi on it, since I changed it, I would actually have to take 30 and divide it by 4. Or divide it by pi. Okay, so we're going to hit 30 divided by pi. Leave that number in your calculator. And then we're going to take that number divided by 4. Leave that number in your calculator. And now it equals r squared. Now we got to take the square root of that whole thing. Okay, and that's where you could go back and use that last answer, that A and S button that we've talked about in the past. You could go take the square root and then hit second answer and get there. Okay, what do we get here for R? Anybody punch it in? Dylan, did you punch it in?
I got 2.39.
Okay. Does that sound right? Everybody get 2.39? I don't have the number here, so, because I just made that one up.
2.39 as r squared.
Oh, r squared. Did you take the square root of 2.39?
Oh, no.
Okay. So then what did you get, Hannah?
For the just r, I got 1.55.
Okay, 1.55. Okay, does that sound better? Everybody able to get to that? Okay, so really big deal. Make sure you know how to use your calculator. I know I've said that a lot, but don't wait till Friday to be like, hey, can you show me how to do this, right, in the middle of the quiz? Know how to use your calculator. Every calculator is a little bit different on the sequence that you got to type it in. So just make sure you know how to use your calculator there. Okay, volume, okay? When we talk about volume of a sphere, okay, we could talk about how much whatever it takes to fill it up, but the most logical thing we would be talking about here is if I had a ball I would be maybe putting air in it. How much air would it take to fill up this ball to get it fully inflated? And so it doesn't even have to be something physical. It could be, like we're talking about here, air. How many cubic centimeters or whatever would it take to fill up that ball? And or if you had an actual physical something, I could put water or something in it. But how much, whatever, can I put into it? The formula for volume, this one's a little bit different. 4/3 pi r cubed. Okay. 4/3 pi r cubed. So a couple of things to notice here. R cubed is because it's volume, it's cubic, right? And that's one way to think of it. So this is r cubed instead of r squared. And kind of like the last couple of days when we did volume, we had to divide by 3. So we're taking that 4 and dividing it by 3. So we just go ahead and write it as 4/3. So those are the two things that are different here. Everything else is pretty much the same as what we did on the last couple of problems. So here we're finding the volume of a soccer ball. And if they just flat out give us the radius, then we're ready to go. Okay, we have everything that we need. So we're going to go 4/3 times pi times 4.5 cubed. Okay, so a couple of things that you would need here. You need probably your fraction button. A lot of you have a fraction button. If you don't know how to use that, ask and I can show you how to use that. That would be pretty ideal to use here. Also, the cube button. Some people have asked me the last couple of days, how do I cube something in my calculator? I'm assuming most of you have done that before. If you haven't asked, most of your calculators, it kind of looks like a caret. In some calculators, it says like x to the y or y to the x. It's an exponent key. There are a few calculators that have just an actual x cubed button on them, but not all calculators do. Like most have the x squared on them. Some have the x cubed on them, but not all of them do. So you might have to use one of these two buttons to do that. This one we should be able to just type in right as we go. 4/3 times pi times 4.5 cubed. Make sure you're only cubing the 4.5. You don't want to cube the whole thing. When I wrote this one down, I rounded it to the nearest tenth. It didn't really say what to round it to, so you could round to the nearest tenth, nearest hundredth, either way there. Okay, anybody need help with their calculator there? Everybody find the button they need on the calculator for cubed? Okay, here they give us the surface area, and we want to go from the surface area to find the volume. Okay, in order to find the volume, what one dimension do I need if I have a sphere? What dimension is in both formulas for surface area and volume? The radius, right? We need the radius, right? If I'm going to find the volume, I need the radius. They don't just come out and tell me what the radius is. It'd be a whole lot nicer if they do, but in here they do not give us the radius, so we got to use the surface area to find the radius and then put the radius into the volume, okay? So we got to work backwards before we can work forwards. Surface area is 4 pi r squared. So make sure you use the right formula. Surface area is 4 pi r squared. That's the number that we're given here. So I'm going to plug 324 pi in for surface area. Okay, as we've talked about, I can knock out the pi's because both sides have a pi. I could take 324 divided by 4. Which gives me what? 81, okay. So 81 equals r squared, and then we got to take the square root like we've done, and we get 9. Okay, my radius is 9. If it said what's the radius, we'd be done. But it says what is the volume. So now we're going to write out the formula for volume. I'm going to take this number here and I'm going to plug it in for R. We now know what R is. So we're going to go 4/3 times pi times 9 cubed. Okay, and now it's kind of like the one we did just a second ago. Just plug it right into your calculator. Okay, well, we're finding volume, so it'd be centimeters cubed. Okay, everybody good? Calculator there? Know how to do all those things? Anybody need help with any of that? Okay, let's skip over this one here because it's basically the same problem, just different numbers. Let's go down to this one here. Okay, in this one, we want to find the volume and surface area of this hemisphere. Hemisphere, the prefix hemi means half. So it's half a sphere. So it's a sphere cut in half. Okay? And first thing we want to do is we want to find the surface area. We're going to do the surface area, and then we're going to do the volume. We've got to do them separately. So we got to kind of break this down. Okay? So first of all, we have to find the surface area of a sphere, but we only want half of it. And so what we would do here first we're going to do half of the surface area formula. But then what we got to do here we also then have to cover the top of it up. If the sphere was an entire sphere, I wouldn't need to cover that top of it up, right? But if I cut it in half, I got to cover the bottom portion, which is this, and then I got to cover the top portion. Well, what kind of figure do we have on top of this hemisphere? What is this shape right here? Yeah, it's just a circle, right? We got to cover up the circle on top. So that would be pi r squared. We got to find the area of that circle. Okay, now I'm going to show you a little bit of a trick here. Try to do some math to make this a little bit easier. What's half of 4? 2. So this is 2 pi r squared. This is 1 pi r squared. So if I have 2 pi r squared, that means I essentially have 2 circles. And then I have another one. So now essentially I'm covering up 3 circles. Okay? So for this, I could just use this formula right here. Okay? Because we got the bottom half and then we got the top. If you want to do it in separate parts, you could do it in separate parts, but I kind of like breaking it up into a smaller part, make it a little bit easier. What would the radius of this hemisphere be? 6, right? 12 is the length all the way across, so make sure that we use a radius of 6. So we're going to go 3 times pi times 6 squared. Says round to the nearest hundredth. Okay, let's do volume. Okay, the volume, we have basically half of a sphere. We got to fill up half of the ball that we have here. So when I do volume here, I'm going to do 1/2 of the sphere formula. Okay, this volume of a sphere is 4/3 pi r cubed, but we're only going to fill up half of it. We're not filling up the whole thing. My radius is still 6. Now the good thing here is you could probably just type that all into your calculator all at once in most calculators. 1/2 times 4/3 times pi times 6 cubed. Okay, try putting that into your calculator and see if you can get it. A couple of different fractions here that could possibly throw you off. Everybody know where their fraction button's at on their calculator? Hopefully by now we've used it several times throughout the year. Hopefully you know where your fraction button's at and you don't have to just use your division button. Carthay, did you get it? What'd you get, Ben?
I got 452.
Okay, good. 452.39 inches cubed. Okay. Everybody good with that? Everybody able to get that? Okay. I probably won't do both of these. I'll talk maybe about each one of them, but we'll work through one of them and then kind of just talk about the other one. So let's start with the one on the left. I think there was one very similar to this yesterday on our homework, but it was more for the surface area as opposed to volume. Here we're talking about the volume, and it's kind of hard to identify what's going on here. Basically, if I have this cylinder, okay, circular bottom, and I put this half sphere, this hemisphere inside of it, how much volume would I have? Okay. So we're going to take the volume of the cylinder minus the volume of half a sphere, okay? And you could say hemisphere, but I'm just going to put half in there because we're taking half of a sphere out of that cylinder. This is where you're probably going to either go back in your notes or you can use that formula sheet on the last page because we haven't really talked about a cylinder today. Actually, been a couple of days since we talked about a cylinder. The volume of a cylinder is pi r squared h. I like to write the formulas out as we go here. And then this would be 1/2 of 4/3 pi r cubed. Okay. Volume of the cylinder formula minus half of the volume of a sphere. Okay. So I'm just inputting those two formulas. This is all I've done. I need two things here. I need the radius and I need the height of the cylinder. So the radius is 2. It's half a way across. The height of the cylinder is also 2. So this would be pi times 2 squared times 2 minus half times 4/3 times pi times 2 cubed. Okay. One thing that I've kind of showed you over the last couple of days, especially with these pies, trying to do this whole thing in your calculator all at once. Some of your calculators will do it right. Some are going to really struggle with this because there's so much going on here. You got to really watch your parentheses and order of operations and all that stuff. So one thing that I kind of like to do is simplify this into a little bit smaller or easier portion. So 2 squared is 4. 4 times 2 is 8. So this part over here becomes 8 pi. Over here, I could take a half times 4/3. When I multiply two fractions together, all I got to do is multiply the two numbers across. So this would be 4 times 1. This would be 2 times 3, which would be 4/6, which is really 2/3. And so this would be 2/3 times pi times 8. If you wanted to simplify it even further, you could. Eight is considered to be like 8 over 1. So I could do 2 times 8, 3 times 1, which is really 16/3. Okay? I feel like this is much easier to plug into the calculator. There's a lot less error that could be made. Okay? Some of your calculators might be good putting this whole thing in, but you might need to use parentheses or things like that. So you just got to kind of play around with your calculator, see what it's going to allow you to do. The ones that display everything in their screen are a little bit easier to work with. The ones that don't, that makes it a little bit more difficult to do. Okay? If I put all of this in, we get about 8.38 inches cubed. Okay, this one over here, I'm not going to work through the whole thing. We have two different figures here. When they say a composite solid, it's basically two different three-dimensional figures that are put together. We kind of saw it yesterday with the kind of grain bin looking one that we did. What kind of figure is on bottom? What do we have down here? What's the bottom half of that figure? What three-dimensional? Yeah, it's a cone, right? So the bottom is a cone. So we would find the volume of the cone. Plus, and then the top, be kind of like an ice cream cone, right? We've got the cone on bottom, and then we got a scoop of ice cream sitting up on top, and that is half of a sphere, okay? We're going to assume there's nothing inside, so half of a sphere. And then you can put all that in, okay? So it'd be very, very similar. You just got to identify what the two figures are, and then how we're going to get that. On this one, we subtracted because we put it down inside of the cylinder. On this one, they're sitting on top of one another, so we added the two together. Okay, so you just kind of have to decide how is that sitting and what are we going to have to do with the two numbers once we get it. Okay, that's our last lesson of the semester, of the year, guys.